Hello. Average fixed cost. Now, why should we know the average fixed cost, average variable cost, and average total cost? The per unit cost explains the relationship between cost and output in a more realistic way. So, from total fixed cost, total variable cost, and total cost, we can obtain per unit cost. So these three are the per unit cost: average fixed cost, average variable cost, and average total cost. Now for the first one, average fixed cost. So average fixed cost refers to the per unit fixed cost of production. So it is calculated by dividing total fixed cost by total output. That is what written, AFC is equal to total, that is TFC divided by Q. So AFC average fixed cost, TFC total fixed cost, Q is quantity of output. So as per the table what we have seen earlier, you find the TFC 12 for all the outputs from 0 to 5. So you are dividing 12 by 0, so you get infinity. Average fixed cost 12 by 1, 12, 12 by 2, 6, 12 by 3, 4, 12 by 4, 3, 12 by 5, 2.40. See, these are the points. These are all value of average fixed cost. So that average fixed cost is shown here in the diagram. So AFC falls with rise in output because total fixed cost is divided by increasing output. So AFC curve is obtained by plotting the points given in the table. AFC curve is a rectangular hyperbola. That means the area under the curve remains same at different points, which we have already learnt. For example, if you mark this point 1, so 12 here, then 2 you find 9. So here this rectangle and this rectangle you find the size remains the same. That is what hyperbola. So AFC curve slope downwards as AFC falls with increase in output. So when it was 1, 12, so 12 by 1, 1. When output is increased to 2, 12 by 2, so it becomes 6. That is what AFC falls with increase in output. AFC curve is a rectangular hyperbola, and AFC does not touch the axis, neither x-axis nor y-axis. It approaches both axes, it gets nearer and nearer to the axis but never touches them. AFC can never touch the x-axis as total fixed cost can never be 0. That is why you don't find the curve touching the axis. AFC curve can never touch the y-axis because at 0 level of output, TFC is a positive value, and any positive value divided by 0 will be a infinite value. So you find that is when output is 0, total fixed cost is 12. When 12 is divided by 0, you get infinity. So that is what meant here. AFC curve never touch y-axis because at 0 level of output, TFC is positive value, and any positive value divided by 0 will be an infinite value. Now next we will see average variable cost. It refers to the per unit variable cost of production. It is calculated by total value total variable cost divided by quantity of output. So ABC is equal to TVC, total variable cost divided by quantity of output. So here you find x-axis represents quantity of output and y-axis represents average variable cost. So average variable cost, you find here initially it falls with increase in output. So the output gets increased and you find the ABC starts falling. And once the output reaches the optimum level, ABC starts rising. It can be, you can make out with the diagram. So that this diagram shows how the ABC functions, or how does, what is the value of ABC, and when it is plotted or when it's marked in the graph, you find it initially falls and once the output reaches the optimum level, it starts rising. So ABC, here you find is a U-shaped curve. As it initially falls and remains constant, here you find it remains constant for a while and finally it starts increasing. So when total variable cost is 10, output is 2. So average variable cost is 5. When total variable cost is 15, output is 3, then average variable cost is 5. That is what here you find 5, right? So it is constant and it increases. The next one, average total cost. Average total cost refers to per unit cost of production. It is calculated by dividing total cost by total output. So here you find average cost is equal to total cost divided by Q. Let me make it clear. Total cost divided by Q. So AC stands for average cost, TC stands for total cost, Q stands for quantity of output. So average cost can be defined, is also defined as the sum of average fixed cost and average variable cost. Let me write it here. Average cost can be defined as the sum of AFC, average fixed cost, plus average variable cost. So when you look at the diagram, you find average cost also initially falls with increase in output. Once the output rises till the optimum level, the AC starts rising. So let me read out the values. So when 0 output, AFC is infinite. Then when 1 unit of output, 12 AFC, so ABC is 6. So average cost is 12 plus 6, 18. When output was 2, average AFC is 6, ABC is 5. So AC is 11. Then when output is 3, AFC is 4, ABC is 5. So total 9. 9 is AC. Then when output is 4, AFC is 3 and ABC is 6. So AC is 9. When output is 5, AFC is 2.40, ABC is 7. So 2.40 plus 7, 9.40. That is what plotted here. So when both AFC and ABC fall at the till the level of 2 units of output, AC also falls, that is till point A. That here point A is here, then point B. From 2 units to 3, second unit to third units, AFC continues to fall, but AVC remains constant. So AC falls. That is due to falling AFC till it reaches point B. From third unit to 4 units, fall in AFC is equal to rise in ABC. So AC remains constant in this position. Then after 4 units of output, rise in ABC is more than fall in AFC. So AC starts rising. When you read this, you can have the tabular column given for the in the previous video, that to calculate total cost, total fixed cost, total variable cost, total cost. So that the same tabular column but divided by the output. This is how you get all these points which are plotted here in the diagram. So AC curve will always lie, that we will learn the relationship between AC, ABC and AFC in the next video.